Any power savings equals more GPUs. So, and then all of the infrastructure that's not providing direct compute equals more tokens for us.
Absolutely. Anytime you spend power moving bits, you're not computing with those bits, and therefore that's not a good way to spend your power.
Hello everyone, my name is Rich Underwood. I'm a HPC systems architect here at Lambda, and we have a very exciting unboxing today with the new CPO switch.
And I'm Ashkan, Network Director at NVIDIA, responsible for interconnect solutions, silicon photonics, and co-packaged optics.
So today we have the NVIDIA Quantum X CPO switch. Here at Lambda, we are really looking forward to deploying the CPO switch due to lower TCO, better resiliency, and all of that turns into lower power, which means we get more GPUs.
The Quantum X3450 switch is a 115 terabit switch with 4 switch ASICs inside and 72 ports of 1.60 terabit, all delivered by an integrated co-packaged optics silicon photonics solution.
One of the first things we notice, right, is I don't have to unpackage and install a bunch of transceivers, a bunch of pluggable transceivers. So when we talk about transceivers no longer being needed in this switch, we look at, I have 72 ports here that I need 72 transceivers. When I say this is a 25 watt transceiver, that equals a lot of power savings. So all of this power savings equals more efficient GPU and more efficient compute time. All of that compute time equals more tokens for us.
That's right. So the benefit of CPO is that it minimizes the electrical channel. So now the electrical channel that leaves the host turns into the optical domain immediately on the package, as opposed to traversing to the faceplate. So the transceivers are gone, DSPs are gone, and that results in the power savings and the more reliable electrical channel, which means better GPU uptime. Because you don't have transceivers anymore, it's just basically glass and plastic on the face. And as we always say, the most reliable network component you have is the one you don't use. So by reduction of lasers, not requiring DSPs, and simply relying on the house fibers to be clean and ready to go, we're able to stand up the system faster.
I've reduced a lot of parts that I have to order, I have to deal with supply chain, I have to install. And then once we go into production, this is a more resilient switch as I've removed a failure point. So when we're talking about super intelligence cloud, we're looking at 128,000 GPU cluster. We potentially need 5 million lasers. In co-packaged solution, that drops us down to 1 million lasers. So really a lot of savings. That total savings equals reduction in power, which equals more GPUs, more tokens. Now we want to talk about the infrastructure needed to support this new type of switch. What's really important when we look at the backside of the switch here, we see that we have a DC bus bar connection and we have liquid quick disconnects on both sides here. So from updating our infrastructure, we have to move to a full rack scale deployment. At that rack scale, we're going to cool multiple switches with liquid. We're reducing all the fans that are running. When we reduce the amount of fans that are running, we have more power available for GPUs.
At a high level, what photonics loves is a stability of temperature, and they don't love changes in temperature. And so this improves the lifetime of a laser by keeping it at a constant inlet temperature, as opposed to wildly fluctuating in traditional air-cooled data centers.
So now the customer experiences less drops, less flapping, and their jobs continue to run. We bring all of these advancements together to get quicker time to tokens, more tokens, and resilient customer experience.
The most successful network is the one you don't think about because it's just working.
Yeah, that's great.